Look what I have. This is a bunch of instances. Let me scale that. Okay, so today's topic is my experimentation on audio visualization. And I'm learning this topic as I go. So maybe from the start, what I have prepared? Basically almost nothing. But this thing will show me the amplitude of each frequency, each part of the spectrum. And first, the total basics. I mean, you can do it however you like, but what I did is an instance static mesh, okay? And this instance static mesh has just 48 instances, and for each of them I calculate a transform, which is here instance separation 25 centimeters, and instance is given the proper position. So this is generated. I didn't want to do it manually. And 48 because when we analyze the sound in Unreal, which I will show later, but first I'll explain that quickly. It can give you 48 bands like this. So now in Blueprint, this is the static part, generating these cubes. Add instance, a new transform. Like the details don't matter much. These are just the index of the cube times separation makes the location of the cube. Okay, basic. And now here's the tangled mess of my experiment. So from the very beginning, what do we want to do? Let me open Audacity. Let me open the sound if it's here. Oh yes. So I have a bit of music, the same music as you have when you wait for the stream to start. Just tell me if I play this. Can you hear it? Does it play on the stream? Hi Piotnashkin. Happy New Year to you too. Nope. You can't hear the music. Huh. Wait a second. So maybe not was-API, but MME. Yes. Mono. Where does it take the desktop audio from? Properties. Device. Audient. Maybe no. Wait, I need to make it. Okay. Maybe no. Can you hear the music? Still? Nope. But this... but Streamlabs is showing to me that you should be able to hear that. Okay, give me a moment. Oh, here it is. Okay, maybe no. Do you have the chill music? Yep. Perfect. Is it too loud or is it okay? Distorted. Huh. Okay, but you can get it. That's good. So, it's not chill. Reminds of Deus Ex. That's a good comparison. Okay, so equalizer, graphic EQ, select audio, graphic EQ, right? So these are the frequencies, And what I would like to visualize is something, let's say, if the bass is mostly playing, then you expect something like this, right? So the lower tones will be intense, the others will be something. There are multiple instruments. So here you have the bass, here you have the high sounds. So, you know, in music, low refers to the left side of the spectrum, the small values of the frequency, and the high are the high values of frequency, with human voice being somewhere in the middle. We have multiple frequencies. And for example, you know, bass guitar closer to the left. And as you can see, this is not linear. This is, I think, logarithmic, but correct me if I'm wrong. So you have 1000 in the center, but you have 100 more than halfway to the left, and it starts at 20 in this case. And of course, on most, you know, on most systems, you couldn't hear below 40, probably. On some speakers, even higher. And the same with the, let's say, ultra sound. So this is what I would like to get. And of course, this can't be calculated for the entire track. It has to be some slice in time. But as far as slices in time go, this is how the sound will look like the loudness of everything when you zoom in. So it goes up and down, up and down. So we would need to pick some period and analyze this as a whole, as an entire thing. Because a single, let's say, frame won't tell us much. That you can't pick an infinitesimally small part. You need to pick something, because otherwise it will be too jittery and you know, chaotic. So that's the theory, and now let's go here. How do you import a sound to Unreal? You need to make it into a wave format. So I recommend Audacity, this program. It's free, it's awesome, it got you covered basically when it comes to audio needs for basic editing. You open some track, maybe MP3. There is a chance that you may have to get FFmpeg to have MP3 support, or lame in this regard. Yeah. So you go to Preferences, Libraries, and you download that stuff. Or you download Audacity with lame already built in. There is such an option. And then you restart, and then you have MP3 support. So you get your sound, you go to File, Export. If you want mono, you can do tracks, mix stereo down to mono, because normally you will see 2 channels. And then you go to File, Export as Wave. And yeah, in the default settings, signed 16-bit PCM, you export as wave. When you have such a wave, you just drag and drop it into Unreal, and what you get is a sound wave, like this. It shows you the duration, 121 seconds sample rate, and the options are, there's a lot of options, but they're not that important. One that I used is looping here, that the sound, you know, will continue to play after it ends. Legovny says that sound is discrete on a computer, so there is a smallest possible time slice. That's true. That's technically true. Okay, so we have that. Now in our BP, let's start from scratch, I would say, because you don't need all that chaos that I have. Here we go. Okay, so in the event graph, I need to update this every frame. Doesn't have to be every frame. You can make a timer, you know, event tick is not recommended, but it's good enough for now. And I just made a single function for clarity, update audio visualization. And I also have a function to play the sound because I want to, you know, have the same thing playing and seeing it on the screen. How do you do that? You add a component called audio, like this. You just specify the sound, which is our sound. Oh, sorry, it's off screen. Audio. Here you have sound, and just drag and drop the sound. And then you do play on begin play, so on the beginning of the game. You can specify the start time, but not necessarily. And that's it. So we have the audio, but it's not what we use for analysis. Analysis has to be, this as for now, performed offline. So not in real time, because it takes a while to analyze the entire sound. So what you do instead is you enable a plugin called Synesthesia, like this. And then you right click. Wait. Whoa. How to scale? You right click, go to sounds. Of course it's off screen. How can I show this to you? Can I? Or maybe through create? No. Oh, come on, Unreal. Okay, I'll make a screenshot for you. Like this. Okay, now you can see that. So you can, right? Sounds. And there is analysis with this plugin. And you have Synesthesia NRT and Synesthesia NRT settings. So you need to create both. So I created, let me show you. When you do Synesthesia NRT, you have to pick the class. And there's onset, there is loudness, and there is constant Q. So loudness is like the perceptual loudness of the entire, you know, of everything that's playing right now in the track. So this is just a single value. A single value. If you use normalized loudness, which I can show later, you will have it between 0 and 1, with 1 being the loudest part. And you have constant Q, which gives you like the individual frequencies. So I created both, and you need to create relevant settings of the same type. So sounds, analysis, and synesthesia settings, same type. And how does it look like? We have this synesthesia NRT. It has just two values, two properties, the settings and the sound to analyze. And this thing, this asset, contains the analysis of the given sound. So here we have it. And this is how the settings look like. You have starting frequency, the lowest, number of bands per octave, default is 12, and analysis period. Period being this, you know, period being this. So some slice of time that we'll analyze. You also have an option to downmix to mono, so you don't have to deal with two channels. And that's it. Then you have some extra settings which are hidden by default. And now in Blueprint, every frame, so on tick, let's disconnect this mess, comment temp sheet, and here we need to create, it's off screen again. We need to create a variable of type some of the NRTs, so either loudness, NRT, or constant Q. So I created both. CQ is the constant Q and loudness. So let's show you what the loudness gives. It's the simplest. You drag and drop it, get loudness at time, or get normalized loudness at time. Normalized will be from 0 to 1, regardless of the units of the, guaranteed range. And then you have to provide time. So time in this example will be get game time in seconds. So this is time since the game started, but it stops, it's not accumulating when the game is paused. And also it takes into account time dilation, so slow motion speedups. So we get it here, and that's it. And then I don't need, all these cubes to visualize that. But anyway, let's do it. Wait a second. Okay, instant static mesh. Get instance count. Of course, I know the instance count, but you know. And then for each instance, what? For each, not array. For, not for each. For loop. From 0 to instance count -1, because it expects the last index, which is very annoying. For every instance, we will calculate its height. Here it will be the same, because these are not frequencies, this is just loudness. But we'll fix it later. Okay, so for every instance static mesh, update instance transform, instance index is this, mark dirty only on the last one. But we don't care about optimization. Normally you should do it only on the last instance, but I'm fine with doing it on everyone, on every single one. Now the transform. So the transform has to be my calculated transform for the instance. It is my own function. It is just separation between instances times the instance index. So separated cubes. It's simple. So this, and now I have to combine transforms because this is just the base. And there is not combine, it's called compose. Compose transforms. So this make, which will mean that this transform will be added to the basic one. So I want to add the loudness as the Z, but multiplied by some scale. So loudness scale. It will be 1 meter by default. 100. 100, right? So this loudness will be my new relative Z. Okay, now you can see it, I think. So we have, for every instance, get normalized loudness at the time, which is current seconds. Add this to Z and set the instance transform. Uh-oh, spam bots, please kick them. Moderators, Adder or Regomir. Or maybe I can. Okay, thank you. Thanks, Regomir. How can I hide this now? Okay. Cool. Okay, so let's try. We have that. We are updating the instance transform. Let's play this. You can see them moving, right? We can make the amplitude higher. So loudness scale will be 400. Yeah, but we can't see it clearly because the entire track is quite intense throughout. So let's download another sound. I had it open somewhere. Oh yes. freesound.org. Great website, right? So we can try some, I don't know, bell. We'll need to look at this. Wait, maybe I'll make the desktop audio not that loud. Wait a second. We'll need to play this again. I was playing with the, sorry. I was playing with the microphone loudness. Is this volume okay? Sorry, I have no way to check. Tell me, chat. Or is it too loud? Was it? I don't want to, you know, do a massacre with the loudness. Current one is like muted. And now? A little too loud. Maybe like this. Perfect. Okay, cool. So let's try here. Yeah, should be the same. So let's try another sound. There are handbells. Yeah, this may be painful. I know it's like playing the ringtones on the mobile phone. Oh, this one's silent. It took ages. This one's crazy. Can I sort by something? Sample rate, channels. Okay, this one's nice. Let's get it. Attribution, all right. Save. And let's drag and drop it here. Great. Looping, it's not necessary. Or maybe not. Okay. So I need an NRT for this. So sounds analysis, synesthesia and NRT, loudness, and it will be NRT, bell sound, loudness. Cool. I open this, select that sound. Loudness doesn't have any relevant settings that I need to change. It's just minimum frequency and that's it. Okay. So now let me replace that. Let me replace that stuff. We have audio. So I will bring it here. And we have this example music loudness, replace with this. Loudness, yes. Wait a second. List. Okay. This one. So now let's try. What? It's constantly playing something? It didn't change. Ah, okay. And the audio should also have the new sound, yes. Yep. As you can see. High initially and then falling down. So here's our loudness. So now let's take a look at the constant Q. So again, where is it? Sounds. Constant Q. NRT. Bell sound. CQ. And the sound will be this, and we can use the same settings. Do we have them? Here. Okay. So now the constant Q will be replaced. C, Q, where are they? Oh yeah. And let's try this one. So now, instead of getting loudness for every instance, we will get CQ, get normalized channel constant Q at time. And this returns an array, not a single value, because these are multiple frequencies. So seconds is the same, channel is 0, because I don't care about stereo. Okay. So now we have a problem because we need to read from an array. But this is not a problem at all. Let me move this to the top here. And we'll do a sequence. So at first, I need to save this array somewhere, because this will be faster this way. So right click, promote to local variable, constant Q. And set this. Now I have an array. So I can drag and drop it from here. And again, for every instance, instead of reading this normalized loudness, I will get an appropriate value by using the index of the loop. So you know, the only important thing is I need as many instances as I have values here. So I need a check. I need to check first a branch if I have enough values. So constant Q, get length, or just length. If this length, no, if my current index is smaller or equal than the length, no, smaller, not equal, just smaller. As long as it's smaller than the number of items in this array, it's okay to read. So only if, then update this instance transform by getting this current value, and again multiplying this by amplitude scale, which is my setting, custom setting. So detach, I'm detaching this loudness. I'm using that like this. And again, just to remind you, this is the normal transform of the instance that moves it along the line. And to it, I add location Z. Add is called compose when it comes to transforms. Okay, so updating instance transform. That's it. Mark render state dirty, so it knows it has to update the graphics. Normally, you would only do it for the last instance. This is the optimal way, but I don't care right now. I prefer simplicity for now. Okay, so only if I have enough values coming from this get normalized channel constant Q, then I read and update. Let's see. Oh, that was fast. Hey player, point at something meaningful. Okay. You know what? We need to make them brighter. So let me change the material to something glowing. Or maybe I have them here. I have only so few materials. Galaxy, come on. Geometry meshes. Debug UV. Oh, really? Audio visualization. Okay. Audio with EQ. Okay. So I can use this occasion and colorize them. Wait a second. How did you get the normalized position of an instance? It was something like vertex interpolator, right? Or no, UVW, bounding box based, lerp. No, just lerp. Okay, maybe cool. From free colors. This, and that. Emissive, unlit. Okay, from red, orange, something, through yellow to green. Okay, cool. Did it work? It didn't because I haven't assigned the material. EQ. Did it work this time? Oh yes. So a very simple trick. This bounding box based UVW will give you a gradient from 0 to 1 for each axis for the entire instanced static mesh. So not per instance, but for the entire thing. Okay, now it's much better. We might multiply it by some brightness. Or emission. Default 2. Perfect. Okay, let's try. Huh. So what you were probably able to see, I know it's quite fast. We may make the sound looping, actually. Is looping, yes. Is that the high frequencies of this bell are visible while there is no bass. Take a look. Right? So only the right side is bumping. Like this. While now, let's try some percussion thing. So, I don't know. Oh gosh. Or drum. Let's try drum. Rattle drum. No. Some lower. Drum. Low. This is quite low. This may be nice. Let's try this one. It's not wave. God damn it. This is cool. Okay. Loud drum wave. Download. Save. What? No. SMD drum low. Now this will be looping as well. And I need an NRT for it. So sounds analysis, synesthesia NRT, constant Q, NRT drum low, constant Q. Here we go. And settings will be the same settings I use for everything. So NRT settings, constant Q, perfect. And now let's replace that. So blueprint. Let's rename it to sound CQ, sound loudness. I don't have loudness for now, so I have to clear that. Can't I? Clear, okay. But CQ will be this drum low, and the sound itself will be this. Where is it? Drum low. Okay, cool. Let's see now. Well, it's not the thing that should be playing. Why? Wait, I have audio. It's here. Drum low. Yes. So what else is happening? I drag and drop it accidentally. Yeah. But it's stopping. I don't know why. Sound CQ is drum low, yes. Downmix to mono, number of bands. But is this thing looping or not? I know what's going on. So here we have time, right? But this time goes into infinity. So I need to take a modulo of that. Modulo, which is symbol percent of length, duration of the sound, so that it loops like this. So, you know, seconds will be rising from 0, 1, 2, 3, 4, and so on. Let's say the length is 12, so up to 12, and then back to 0. Up to 12, back to 0. This is what modulo does. It starts to loop the value after the given period. And now it should be fine. Yeah. So you can see what's going on. There is a bump now at the left side of the spectrum. When you compare it to bell, which was happening on the right side of the spectrum, high sound. So these are the basics. This is really simple with the synesthesia thing. So you create this NRT, you get normalized channel constant Q, or loudness, depending on which type of NRT, which is one of which type of NRT did you create. And then you get an array if this is constant Q, or a value if this is loudness, and you set instances to represent this. Let me look on the chat because I haven't for a while. On the chat. Piatnashkin says it works too well. Yeah, there were some old methods that weren't too... They were really hard to use. Because, for example, I've used a plugin where you had to recreate the result of analysis every time you modified the sound. And here it looks like it happens automatically. I couldn't see any refresh or nothing. Just drag and drop the sound and you get it. Now we can play with the settings. CQ. This is how it works now. By the way, let me rotate this irritating player to be above. So we have a dark background. Okay, cool. Maybe closer. So this is the drum. It's a bit shaky. So let's try increasing the analysis period. Let's try this. 10 times more. Analysis period is here. Yeah, now it's less shaky, as you can see, because we are taking a longer period. Instead of analyzing this, we have an average for this, let's say. If I do a really small number, like 001, I can't, okay. But yeah, you'll be able to see it shaking. As I increase that, it's less precise, it's slower, but smoother. So it depends what you need, right? Slower. Number of bands. I didn't have any success changing this. If I do one, but maybe now, let's see. Okay, now it works. So 48 bands covers the entire interesting spectrum like this. We can also shift the start, let's say at 200. So now as you can see, they still expand to the entire thing, but the lowest frequency was skipped. It's cut off at the left. If I do, let's say, starting frequency 10, 20 is the lowest, okay? Yeah. And you can also here see the logarithmic scale at work. So at the beginning, I have even quite imprecise numbers. And you can clearly see that the base is happening somewhere here. Let me increase the amplitude, by the way. 250. Should be more readable. Oh yeah. And now I take the settings and starting frequency 40 as it was by default. Yeah. As you can see, part of this base thing, the low frequency, is cut off. And there is also number of bands per octave. So this is at 12. Now this will be at 6. At 6. Now if I do 1, this isn't too precise, right? $24. Yeah, now we have so much data that we don't have enough bands. So I could do more bands. And what I think we can do is we can read the number of instances directly from this. Let's try. Blueprint audio visualization, construction script 47. So let's do sound CQ get can I get the number of bands? Get settings, get sound. Okay, I know what we can do. We'll just sample at time 0. So get constant Q at time in seconds 0, and just the length -1. This -1 is so irritating in Unreal Blueprint loops. Okay. So I'm just getting, the actual number that I will have. Number of these bands. And create as many instances. Let's see. I hope it doesn't crash. So now if I reduce this number of bands, 4, this should become, or shouldn't. Yes, it's shorter. So 48 bands, save. It's longer. Great. Let's try. And now let's try number of bands 24. Yeah. But I have to move this? Come on. Yeah, now it works. Okay, 48. However, number bands per octave, 1. It doesn't change. Okay, so this is the only number that matters. Number of bands. We also have the noise floor to cut off sound that is quieter than a given threshold. Noise floor. So wait, here you can see that even if it's becoming like quieter, you can still see the movement. So we can do higher noise floor, -20. Yeah, and immediately drops off because sounds quieter than -20 just got cut off. It's quite abrupt though, quite sharp. I don't know if we can fix that, but probably not. -10 will be very, very sharp. Yeah. So let's go back to 60. Okay, so these are the things you need. And as you can see, this process has a lot of settings, so it's high quality, let's say. So it has to happen offline. On NRT, it's called because it's non-real time. Let's visualize the intro music, says Piatnashkin. Okay, so back to Blueprint. Sound CQ will be replaced with example music CQ. And the sound playing as well. Cool. Quite sharp, right? So let's go to the settings. Is it using them? Yes. Analysis period is quite wide, to be honest. Let's try higher noise floor, by the way, -40. Okay, still intense. Uh-oh. So let's try analysis period of a second. Quite vibrating. I wonder if it takes it into consideration, or do I have to save something again? CQ. Let's save. Yeah, it does. Okay, so settings again. Blackman. What I would like to have is some kind of smoothness post-process. By the way, let's try starting at 20 Hertz. Yeah. Quite funny to look at. So here it is. 40 was better. It was better distributed. Number of bands. So that was the intro music. Now, as you can see, we can pass the info into instances from Blueprint. But I think we should be able to do that also for the shader. So what I would like to do currently is not to move the instances, but rather control the brightness. Okay? So we keep it as it is, audio viz. And I make a new one. It will be audio viz. diodes, because they will behave like diodes. And I'm going to do fewer of those. So the first thing will be NRT setting CQ diodes. Let's place that. And yeah, for these diodes, I will have this other CQ. So again, intro music, example music. Where is it? Yeah, constant Q, but for diodes. Let's open this. Let's use the same sound, but different settings. And in these settings, I will have a lower number of bands, 24, or maybe just 12. And I need to increase this by 4, right? Let me open the blueprint first. Sound CQ will be this diodes thing. Oh, why? Why not? This thing. Yeah. Let's play that. Okay, cool. I can remove this one for now, or at least make it silent if it's possible. Audio, volume 0. Cool. I wonder if it covers the same spectrum or not. No, it's like the same, but just cut. CQ diodes. I may do this, but times 4. I can't. Let's try now. I'm not sure, to be honest. Let's return to the default. Because I need to move this. Damn. Okay, cool. Hey, but this behaves much better. So something is broken with this setup. Where is this default thing? CQ. Something is broken in this setup. Down mix to mono. Looks the same. So why is it different? I don't know. I just create a new one. Wait a second. It should be identical. But apparently isn't. Okay, it is. I absolutely don't know what's going on with these. But okay. Yes. Wait, I have this CQ diodes and CQ standard. They are identical. They are totally identical. And then I have this, and diodes. Almost the same. Maybe I just need to save. No. I'm completely clueless. Let me create this one from scratch maybe. So restart editor. Okay, cool. Cross level tools. Why do you ask me? No. What's going on with this? Hmm. Let me create it from scratch. So I'll delete that. I know that's using it, I know. Sounds analysis NRT, constant Q, NRT, example music, okay. Sound will be example music, save. And now in the blueprint, it goes here. Now it behaves better. Okay. So either I don't know how to refresh this, or sometimes you may have to create a fresh NRT when you are done playing with the settings. I don't know, but now it works smoothly. This is our starting point. Now I would like to have, where are my variables? Variables, come on. I need instance separation visible. Instance, here it is, okay. So I want to have less of those. So instance scale will be like 0, 2, 0, 2, 0, 2. But I want to have bigger separation, like 50, and less of them. So CQ diode settings, number of bands 24, save. Huh? Nothing? Wait. Sound CQ is diodes, it's fine. And on the construction script, I'm using the number from the sound CQ. So what in hell? Diode settings, 24 bands. Okay. 5. Nothing. So maybe I have to open this diodes thing and now save it or something. Huh. Clear. It will crash. Damn it. Oops. Use an empty. Awesome. Oh, and MDS Ubuntu. Thank you for following. Recent levels. Audioviz. No. That's bad because I saved this asset. Commit. Which was it? It was example CQ. It was diodes, right? Let's delete this. I cannot submit the sound. Let's try now. What do you mean, Piatnashkin, finally? Finally what? Audio viz. It was working too well, exactly. It was too easy. Not enough for the long stream, so it's cool that it crashed. You're right. Okay, sounds analysis, NRT, constant Q. NRT, example, music, constant Q, diodes. Now let's go to the settings of these diodes. There are too few bands, or what? 12. What did I do? Did it broken? I know what I did. Example CQ diodes, I deleted the sound. So the sound is here, and the settings are here. Let's try. I have to reconnect. Sound CQ here. Okay, cool. Finally. So I have what? 1, 2, 3, 4, 5, 6, 7, 8, 12. As I said here, number of bands 12. Cool. So now does it represent the same thing or not necessarily? Let's try lower instance separation. Let's go. Yeah, so it just cut. And I wanted to scale somehow. Number of bands per octave. Can I increase that? And will it help? Or does it work the other way around? So like 6. And now let me separate this. I'm not so sure, to be honest. Seems like it. Yeah, so to cover the entire thing, I would have to, let's say, wait, 4 or 0.8. 4. Yeah, looks similar. So now, let's make it tighter, by the way, this one. Instance separation 12.5. Yeah. And now I will need to decrease that to 3 or no. Or maybe. Is it an approximation? Looks like it, right? What happens if I do 1.5? I don't know which one was the correct value. 12 is default. And how many bands are here? 48, right? 48 in the CQ, yes. So in the diodes, I cut the number of bands by 4. So I need to cut the number of bands per octave by 4. And it should be represented fairly well. So if number of bands are 24, it should be 6. I think. Maybe I'm mistaken, so let me know. And the separation lower. Yeah, it seems to work that way, I think. Okay, so now instead of jumping, let's do actual diodes. So in this one, I want to get rid of instance moving in this audio update thing. So no moving, no transform. However, we will still need this normalized value of the constant Q. Just use it for different thing. So, let's go to the material, audio viz. Okay, And let's make a switch. Emission is here, it's 2. Let's make a static switch parameter. Don't use too many of them because they add shader variants, but here it's reasonable. So use dynamic emission or use emission from parameter. So if it's false, just use 2. From custom param. These custom parameters are a very clever thing, because normally when you have an instance static mesh like this, then you can only have one mesh and one material. That's why it's so cheap, because it's just a list of transforms, very quick to render, because all of them are referencing same mesh and same material. So it's one draw call and it's super cool. However, you can't assign a separate material for any other instance. So what to do? There is quite a new thing, not so new, but still. You have it in Unreal Engine 4 in the newest release. It's called custom param. You just create a standard parameter like scalar parameter, okay? And let's say emission per instance. Or emission, yeah, per instance. And now you scroll down and you select use custom primitive data. And it gets converted into custom primitive data of some index. You have 32 such, or more, 36 such values for every mesh, and every mesh and every instance in the world has it separately. It has it separately. So basically you have 36 float values that you can set to whatever, and material will pick this up. I will show in a second. When you use a vector, you will use 4 of them at the same time. So if you set 0, it will take 0, 1, 2, 3 because RGBA. For scalar, it's just a single slot. The problematic thing is that these slots are not named in any way. You just have to be careful. So if you want to know more about this mechanism, techart8.com and find the tutorial Interactive Materials. This one. So in it, I compare the dynamic material instance approach versus custom primitive data. I explain the pros and cons, and basically that custom primitive data is way faster for the for the computer. Harder for you because it's harder to manage, but the great thing is how you can per mesh set a specific parameter or even per instance. So let's get this one. If this use emission from custom, use the emission from primitive data is true. By default, it will be false, but we'll make an instance of this material. Mi audio vis EQ diodes. And here it will set it to true. One thing that will happen is that it will become black because custom primitive data can't have defaults, which is a shame. But that's what it is. So that's why you have to have a material instance. So it will become black because I will use it here in this diode thing. Diodes thing. Yes. So they are black by default. However, in construction script, for every such instance, we can do instance static mesh, set custom primitive data float, instance of the same index, and here we do 1. So emission strength 1. Here we go. So maybe half, like this. Half emission. Without changing anything in the material, you can just control this value. And now we can do this divided by the number of instances. So length or count, get instance count, and use it. Oh, does it divide integers? Float, divide. Oops. Yeah, so I have the instance static mesh. I divide this instance index by the total number of instances, and I get the value from 0 to 1. So let's see. Uh-oh, I don't. Wait. Instance index. Ah, it's here, sorry. To float divided by instance count to float. Right. They have to be floats. So maybe this was okay. Oops. Still doesn't work? Why? Oops, data index should be 0. Okay. So yeah, instance index divided by instance count. What? I'm doing something wrong. Instance index divided by number of the total. Yes. Like this. Still nothing. No luck in that regard. Yeah, get normalized channel constant Q at a time. Get length. Divide. Okay, I'm sorry. Instance static mesh. Set custom primitive data, but for yeah. It's called differently. It's set custom data value because this sets it for the entire thing. Set custom data value. Instance index. Now we have it. And custom data value is this. This is our index in the material. So this one, primitive data index. Mark render state dirty to refresh. Yes. Still bad. Something's wrong with me. Whew. Instance index. Should be this, right? I don't know if it's returning an index. Maybe like that. Nothing. Black. Custom data 1. Still wrong? What the hell? Instance static mesh. Yes. Instance index. Index. Custom data index 0. Custom data value 1. So what's wrong? Should be fine. And it's set to use this from primitive data. Or do I have to create them first? I shouldn't. I don't know, I shouldn't have to. So, but we can try. When it's completed, a for loop. where the last index will be static mesh, get count, subtract 1, index, and set this data. Doesn't work. What the hell? Did you set material on them? On this? Yeah, I did. EQ diodes. If I disable, now it works. Wait a second, we have blueprint, right? We are creating instances here. Let's say I don't create them. Okay, now they don't appear. I create them, they do. And then for as many instances as I have, set custom data value. Instance static mesh. Set custom. Set default. Default is default. Set float. Set custom primitive data float. Data index. But this is for the entire component. I don't need component. What the hell? Create a dynamic material instance first. But that's the thing with custom primitive data, Piatnashkin, that you don't need dynamic material instances because it's just reading from this. Or maybe it's broken in early access. That would be weird. That's the beauty, exactly at the set custom primitive data float at index data index. You know what? Maybe it's broken in this early access Unreal Engine. But that would be so bad. Just debug it. Just debug it. Instance index, but is this custom data what I think it is? Custom, maybe there's some custom data. Maybe it's this. Oh god. Wait. So this is something else. So it seems that early access version doesn't yet have the possibility to set custom primitive data per instance. It had to be added later. Sorry. It's this, apparently. Let's try now. Gray. What? Per instance, custom data. Yes. Default value, emission. Doesn't work. Data index 0. Stops. No errors yet. Okay, let's not set them. Doesn't work. Actually, why? Or maybe vertex interpolator. Now it works. What the hell? So vertex interpolator normally gives you vertex shader, but in case of instancing, it gives you the instance, which is stupid and confusing. That's how it is. Okay. So now can I get my normalized thing? So let's get the instance index. to float. And let's remap that, or map, from 0 to instance count -1 to 0 and 1. Like this. Remap. Map range clamped. Doesn't work. Huh. Custom data index is 0. Value is this. Let's print that. Print this. Doesn't print. Actually, why? Print to screen, yeah. Prints to log. It does print to log. Okay, so we have it 0, 0, 0, 4, 0, 47, 0, 73, 1. So every instance is giving me the proper value. So I don't know why this isn't picked up by the material. Or maybe my vertex interpolator hack wasn't correct. Now it's dark. Oh boy. Data index 0. Yeah, but if I had it like this without vertex, it didn't compile. It was gray. This is not my lucky day. I mean, the beginning was so easy. Legomi, how I did learn about the vertex interpolator for instances. I learned from random forums. Yeah. And somebody was helping me. I think Shalivan was helping me with this to get scale per instance. It's a shame that this doesn't work. It would be so useful. Custom data index 0. Or maybe 0 is used, maybe 9. Let's try 9. Apparently not. Is it used with instance static mesh? Yes. Okay. I can't let this. I can't leave it just like that. UE4 per instance data. Custom data. Per instance custom data. Now you can send an array of custom float data. Fantastic. $4.25. You can use the vertex interpolator node. Oh yes, please do. Cool. Number of custom data floats is set to 1. How do you do that? Okay, let's use 0 again. 0. In here, instance calling, instances. I don't have something like that. How do I call that? Num custom data floats. Num custom data floats. Set custom data value. Right. Right. And this is what we had. Like, totally. Cool. Well, this, yeah. Aha. Piatnashkin says that maybe it has to be hierarchical instance. Static mesh. Let's try. Sorry. Let's try. Hierarchical instance static mesh. Cube. Oh. An I diode. Yes. Where is it? Here. And here. And here. And also in the update function. Nothing. Construction script. Still nothing. Whew. Hierarchical thing. Coding, physics, collision, lighting, rendering. Oh god. Custom primitive data defaults. 1. Nothing. It didn't help. Where's this construction script thing? Custom data index, just 1. Compile. Nothing still. Instances. Okay, let's not create them. Let's add them manually. Add. Okay, there's one index. There's a second. Cool. And there was default data, right? Default data index 0, 1. Nothing. And they mentioned about num custom data floats. How do you do that? Oh, there is. In the instances. In the instances. There's something like that? Where? Oh god, it's hidden under the advanced button. Num custom data floats. 1. Let's go. Now I have rendering custom primitive data defaults. 1. Not really. I don't need that. It should be enough now. Num custom data floats in instances, but hidden under the arrow. Let's try. Let's try now. Construction script. Let's attach that again. Let's disable default instances. Instances. Okay, cool. It's already something. Now the value. Oh yes, finally. Damn it. So what do you have to do? You have to use hierarchical instance static mesh component. Thanks, Piatnashkin. You have to go to instances. So search for instances. Expand the advanced thing, and num custom data floats sets how many of such data you can have. So 1, because I just used the custom data index 0. If you want 4 different things per instance, 4, right? Or a color. So I'm fine with 1, which would be my brightness. Okay, so here I tested it. I don't need that, of course, right now, but I will use the same mechanism. So let's delete this. I don't care. It's black. But with the music playing in update audio, I'm gonna have some fun with the brightness. So for every instance, if you have enough values, set custom data value to constant Q of the given frequency for that instance. That's it. And update the render state. Update the graphics. Let's try. Oops. Not really. Not really. Instance index. This is what I missed. Okay, cool. Constantly bright. Because I'm not clipping it or scaling it. It's normalized, it should be. So let's treat it with a power. Power of 3 for now. Okay, great. I just need to multiply the brightness. So where was it? This material? Ah, yeah. So I'm gonna just do 1 multiplied with emission strength. 4 or 8. Okay, great. Use emission from emission per instance. Cool. Okay, now it's too bright. I may also want to change this floor noise setting -30. There's equal energy, maybe equal amplitude, equal Euclidean norm. No. It's not. I want more detail in this. Okay, cool. I reduced the analysis period to smaller. Okay, here we go. Whoops. Let's use black body instead. Okay. So instead of this emission color, black body with temperature multiplied by 3000 and the black body multiplied by emission strength like this. So black body taken from the instance data and then multiplied by brightness. Could use higher values though. 6000. We can also do some kind of history, I think. We could do some history. we can take that and do an offset. So time offset variable float, and let's add this to this time sampling. Time is here, right? Get add like this. Collapse to function, pure functions. Get sound time. Cool. And now I'm going to duplicate those. Disable their sound. So volume, where is it? I can do it like that. Okay. Volume multiplier, like this. Event graph, or no, just play sound. Boolean. It will be true by default. And only if, then do it. Okay. And I will just disable playback for most of these. So let's select those. Play. What? There should be. The eye icon. Play sound false. Play sound true. And now time offset 0, 0, minus 0.2, minus 0.4, minus 1. Let's see. Yeah, so it's sampling the sound at a different time. I could use smaller offsets, by the way. And these diodes, red, green. Let's slap it on it. And this will use the colors, not the black body thing. Just like this. Okay, cool. Smaller offsets, where are they? Minus 0, 0.5, minus 1, minus 0.1, minus 0.15, minus 0.2. Okay. Yeah, makes more sense. Oh yeah, the Gomel is right. We can add some reflections. Let's have it. We can't see it anyway. Okay, so here it is. Audio visualization in Unreal. Have fun with it. Audio components are auto-activated. Yeah, they are, but I added this play sound, so they won't play until I have play sound enabled. Okay, thank you for your time today. There was a lot of you on the channel. It was quite chaotic, I know, but I also learned as I went. And I'm surprised by this instance thing. I'm pretty sure that in actual release of Unreal Engine 5 it will be fixed. So we can do set custom primitive data per instance, and that's it. Piatnashkin says, thanks for streaming. Sure, nice to be here again. Okay, so see ya.